Infinite line. In this section, we are going to derive the sending end impedance of an infinite line. So to find the sending end impedance or input impedance of a transmission line, first we will consider the voltage and the current equations at the sending end of a transmission line. And we assume the sending end of the transmission line is at a distance of L from the receiving end. So the equations of voltage and current becomes Vs and Is for the sending end, and it is Vs equal to Vr cos h root of Zy into L plus Z naught by Zr sin h root of Zy into L, and I is equal to Ir cos h root Zy into L plus Zr by Z naught sin h root Zy into L. Then the input impedance of your transmission line is Zs equal to Vs by Is. Here substitute the value of Vs from this equation and Is from the equations. Then Zs becomes Vr into cos h root Zy into L plus Z naught by Zr sin h root Zy into L divided by the Is value is this one. Then we write the value of Vr as Vr equal to Ir into Zr. Here we replace VR by IR into ZR. Then the remainings are same. Here IR get cancelled. Then it becomes ZR into cos h root Z by L plus Z naught by ZR sin h root Z by into L divided by cos h root Z by into L plus ZR by Z naught sin h root Z by into L. Then we multiply ZR inside the, we bring Zr inside the brackets, then it becomes Zr cos h root Z by into L plus Z naught into Zr by Zr. So Zr into Z naught by Zr. So Zr cancel. Then it becomes Z naught. Z naught sin h root Z by into L divided by here in the second term we have a Zr by Z naught. So we have to take LCM. Then it becomes Z naught cos h root Z by into L plus Zr sin h root Z by into L. The whole thing divided by Z naught. That Z naught comes to the numerator. So Z is equal to Z naught into Zr cos h root Z by into L plus Z naught sin h root Z by into L divided by Z naught cos h root Z by into L plus Zr sin h root Z by into L. This is the input impedance of your transmission line. Then we bring this equation in exponential form. For that we have to use cos h gamma L as cos h gamma L equal to e power gamma L plus e power minus gamma L by 2, and sin h gamma L equal to e power gamma L minus e power minus gamma L by 2. And rearranging this equation means we combine the e power gamma L and e power minus gamma L terms separately. Then the equation becomes Z naught into e power gamma L plus Zr minus Z naught by Zr plus Z naught into e power minus gamma L by e power gamma L minus of Zr minus Z naught by Zr plus Z naught into e power minus gamma L. This is the sending end impedance of your transmission line. Here we apply the condition, that is whenever the load is terminated by its characteristic impedance. From this equation the Zr represents the Zr represents the receiving end impedance. Whenever the load impedance or receiving end impedance Zr is terminated by its characteristic impedance of the line, that is Zr equal to Z0 means this equation becomes, the second term of the equation becomes 0. Since here we are having Zr minus Z0, so it will be 0. And second term of the denominator also 0. So finally we get Z is equal to Z is equal to Z0 into e power gamma L divided by e power gamma L, since the second term of the numerator and denominator tends to be 0. So e power gamma L, e power gamma L get cancelled. Then we get Z is equal to Z0. So when the load impedance of your transmission line is terminated by its characteristic impedance means the source impedance is equal to Z0 of the line. So this is the condition for a finite length. Now we will find the condition for an infinite line. So infinite line means the length of the line becomes infinity. So to find the input impedance of an infinite line, we substitute L equal to infinity in this equation. So to put that, we have to take e power gamma L outside the bracket in both numerator and denominator. So this equation becomes 1 plus ZR by ZR minus Z0 by ZR plus Z0 into e power minus gamma L divided by e power minus gamma L. That becomes e power minus 2 gamma L. Similarly, in the denominator, uh, when we take e power gamma L, outside the bracket means it becomes 1 minus ZR minus Z0 by ZR plus Z0 into e power minus 2 gamma L. Since if we apply L equal to infinity means the e power infinity becomes infinity. E power minus infinity is equal to 0. So, so we have to bring the terms in terms of in the like e power minus terms. So when we bring e power gamma L in the numerator and e power gamma L in the denominator as outside the bracket means both are cancelled. Then we have to apply the condition for infinite line, that is L equal to infinity in this equation. Means it becomes Z is equal to Z not into here e power gamma L by e power gamma L get cancelled, then it becomes 1 plus ZR minus Z0 by ZR plus Z0 into e power minus 2 gamma L divided by 1 minus of this term into e power minus 2 gamma L. When L equal to infinity, and here e power minus 2 gamma L is written as 1 by e power plus 2 gamma L. So when we apply L equal to infinity means it becomes 1 by infinity. 1 by infinity is 0. So this term will be 0. Second term of both numerator and denominator are 0. So we have only Z naught into 1. Because here it is 1. 1 plus 0 divided by 1 minus 0. So we get Z is equal to Z naught. So the input impedance of your infinite line becomes Z is equal to Z naught. Therefore, a finite length is considered to be a line of finite length is terminated in a load that is equivalent to its characteristic impedance means the line is appears to be a infinite line at the sending end of your transmission line. Here we will derive the input impedance and transfer impedance of a transmission line. The input impedance of the line is already we derived Z is equal to Z naught into ZR cos h comma L plus Z naught sin h comma L by Z naught cos h comma L plus ZR sin h comma L. Taking cos h gamma L outside in the numerator term, it becomes ZR plus Z naught sin h gamma L by cos h gamma L. Similarly, in the denominator, the terms are Z0 plus ZR sin h gamma L by cos h gamma L. So sin theta by cos theta becomes tan theta. Therefore, the equation becomes ZR plus Z0 tan h gamma L by Z0 plus ZR tan h gamma L. This is the input impedance of your transmission line. Next, we will derive the expression for the transfer impedance. Transfer impedance means it is the ratio of sending in voltage to the receiving in current. We know that V is equal to VR cos h root Zy into L plus Z0 by ZR sin h root Zy into L. This is the equation for voltage of your transmission line. And here we will write the cos and sin terms in terms of exponential form. So this becomes this is written as e power root Zy into L plus e power minus root Zy into L by 2. And sin h root Zy into L is e power root Zy into L minus e power minus root Zy into L by 2. Then we are grouping e power plus root Zy into L terms and e power minus root Zy into L terms separately. Then the equation comes like this. and this is equivalent to VR by 2, and taking LCM, this becomes Z0 plus ZR by ZR e power root ZY into L plus ZR minus Z0 by ZR e power minus root ZY into L. Therefore, this and here we take ZR plus Z0 by ZR as ZR outside the bracket. Then this equation becomes VR by 2 into ZR plus Z0 by ZR. Then it becomes e power root into e power root ZY into L plus ZR minus Z0 by ZR plus Z0 into e power minus root ZY into L. And ZR minus Z0 by ZR plus Z0. Here we write the term as K. K is nothing but a reflection coefficient. So the equation becomes V is equal to VR into ZR plus Z0 by 2 ZR into e power gamma L plus K e power minus gamma L. So this is the sending in voltage. The transfer impedance is ZT equal to Vs by IR. So Vs is VR ZR plus Z0 by 2 ZR into e power gamma L plus K e power minus gamma L. Divided by IR, and we know that VR by ZR is nothing but IR, so we can cancel the IR term. Then it becomes ZR plus Z0 by 2 into e power gamma L plus K into e power minus gamma L. And this is ZR plus Z0 by 2 e power gamma L plus, here we substitute the value of K as ZR minus Z0 by ZR plus Z0. Then the term and multiply ZR plus Z0 by 2 inside the bracket, the term becomes ZR plus Z0 by 2 e power gamma L plus ZR minus Z0, since ZR plus Z0 and ZR plus Z0 are cancelled, by 2 into e power minus gamma L, and grouping ZR and Z0 term separately, it becomes ZR into e power gamma L plus e power minus gamma L by 2 plus Z0 into e power gamma L minus e power minus gamma L by 2, and this is nothing but cos h gamma L, and this term is cos h gamma L, and this term is sin h gamma L. Therefore, the transfer impedance becomes ZR cos h gamma L plus Z0 sin h gamma